Find the second derivative y double prime by implicit differentiation for sine of y plus cosine of x equals 1. Even if we were not told that it is implicit differentiation, we will need to use implicit differentiation because the y is inside another function, so this equation is given implicitly. First, we set up by differentiate both sides of the equation with respect to x, always with respect to x. The derivative on the left-hand side is the sum. The derivative of sine of y is cosine of y, but that's not good. We're not done. We still need to multiply y prime because the variable in the expression sine y is not x. Every time we differentiate the expression that doesn't have the same variable as the dx in the denominator, we would need to multiply the prime of that variable. The derivative of cosine of x is negative sine of x. This time there's no need to write y prime because the variable is x. And don't forget to differentiate on the right hand side as well. The derivative of 1 is 0. And so we have cosine of y, y prime, equals sine of x. And so y prime equals sine of x over cosine of y. But this is only the first derivative. We are looking for the second derivative. The second derivative is the derivative of the first derivative. And so we will need to differentiate sine of x over cosine of y. The second derivative, this expression is a quotient, so we will use the quotient rule. First, we square the denominator, cosine of y squared. And then we differentiate the numerator. The derivative of the numerator sine of x is cosine of x, and we multiply the denominator minus. This time, we keep the numerator sine of x, and we multiply the derivative of cosine of y, which is negative sine of y. But no, we would need to multiply y prime to this because sine of y does not have the same variable at dx. And then we simplify this expression. Cosine of x times cosine of y is cosine of x cosine of y. A negative sign times a negative is a positive plus, and we have y prime sine of x sine of y. In the denominator, we have cosine squared of y. Cosine of y, the quantity squared, is cosine squared y. There's one more thing we need to do here. There is y prime in this expression, so we would need to rewrite y primes in terms of the expression for y prime that we found earlier, which is we now have cosine of x cosine of y plus y prime is sine of x over cosine of y, and we rewrite everything sine x sine y and then over cosine squared of y. This is a complex fraction, so we can't leave it like this. But notice that sine of y over cosine of y can be rewritten as tangent of y. So this is cosine of x cosine of y plus sine squared x, and then sine over cosine of y is tangent of y. Once we write it as tangent, we no longer have the complex fraction, which is good. If we want, we can go one step further and simplify one factor of cosine of y with one factor of cosine of y in the denominator. But to do that, we would need to split this fraction into two.